So hi, I'm Sebastian. I'm doing things with computers since 1990, PHP since 1998, PHPUnit for almost 21 years now. Thanks to you-know-what, I did not get to celebrate the 20th anniversary of PHPUnit last year. We also did not get an opportunity to celebrate 25 years of PHP. Hopefully, at some point in the future, people will be able to travel again, to meet again, and to celebrate things like that again. Back in 2009, I founded the PHP consulting company together with Arne Blankertz and Stefan Priebsch. And a while ago, back then, when we could still have in-presence real conferences, I was preparing a presentation on PHPUnit for a conference, and I honestly do not remember where the title "Optimizing Your Test Suite" came from. I think that was suggested by someone like, hey, can't you give a presentation at some point on optimizing your test suite? And I thought, yeah, cool. That sounds like a nice title. But what should the abstract for a presentation like that be? So I asked Twitter, what topics would you expect to be covered in a conference presentation titled Optimizing Your Test Suite? I got a couple of dozen results. I clustered the results and got things like faster, better feedback, easier to maintain, more readable tests, better organizational structure for my test suite. I said, okay, cool. Those clustered words, I can fit those into a sentence or a couple of sentences. And that's how the abstract for that presentation came to be. So for this presentation, the guiding questions, what do we want to learn, or what experience and knowledge would I like to share? How can we write readable test code? How can we implement maintainable tests? How can we get better feedback from tests? And how should we organize tests? And of course, being the creator of PHPUnit and the person who maintains PHPUnit and does most of the work, or a lot of work on PHPUnit, these are, of course, not only questions that I look at from the perspective of a person that writes tests using PHPUnit, but these are also questions that guide the development of PHPUnit itself. We always strive to make writing tests with PHPUnit more convenient and also improve the execution of tests with PHPUnit, the command line test runner. So, and of course, how can we efficiently run tests? Well, we start at the beginning, and at the beginning, or in the beginning, there are usually some principles. And when it comes to writing good tests, there have been a couple of principles that have been around for quite some time. So for instance, there are the first properties of unit tests. Tests should be, especially unit tests, should be fast, isolated, repeatable, self-validating, and timely. So fast is hopefully obvious. A unit test should be fast. I should get immediate feedback within a couple of milliseconds. Isolated means that the tests are executed in isolation from each other, that the outcome, especially the breaking of one test, does not have an impact on other tests. Tests should be repeatable. It's really frustrating if you run your tests and you run your tests again and you get a different result. That should not happen. That must not happen. If you repeat a test execution without changing the test code, without changing anything else in the environment, then the test result should be the same. Tests should be self-validating. This is, of course, obvious today, but way back when we did not have test automation frameworks, this was like the key selling point, writing down our expectations for the thing that we want to test so that it's automatically validated. And timely, well, you should not write tests after the fact. They should be written while you're working on the software. If you do test-driven development, they're usually written in advance. And you can change the I from isolated to independent, which basically means the same thing, just looks at the problem from two different angles. Tests should be independent, meaning that you shouldn't have dependencies between tests, which also is a little bit less technical than looking at it. Yeah, I need to execute it in isolation and so on. Just like the first principles, there's also the AAA of testing, the arrange, act, assert. But just like the first principles, if you want to read up on that, I encourage you to go to wiki.c2.com. That is the world's first wiki. And this is a invaluable resource to every software engineer, because this is the wiki where not only the concept of the wiki was created, but also the wiki where the original Gang of Four design patterns were discussed, because before they were published, this is where a lot of the topics from agile and test-driven development and testing were discussed in a small group of people before they became mainstream. And it's not only the wiki where you see the early definitions of what is extreme programming, what is pair programming, what is test-driven development, and so on, but you can also see the discussion that led up to these definitions. So the AAA of testing means each test method should group the functional sections separated by blank lines, arrange all necessary preconditions and inputs, act on the object or method under test, and then assert that the expected results have occurred. So in a simple PHP unit test, this is what this usually looks like. This is taken from a project of mine, like a hobby project of mine that I have on GitHub. It's a ray tracer written in PHP. Don't ask why anybody would write a ray tracer in PHP. A couple of years ago, I came across a book where using test-driven development, the ray tracer is built, and I followed those chapters in the book and did the examples myself in PHP. Back when we could travel, I spent a lot of time on trains and planes. I needed to pass the time, so that sounded like a good idea to pass the time. I mostly use this project, this ray tracer, as a test bed to prototype new features for PHPUnit, to experiment with new ideas, whether or not they make sense in a close to real world example as possible. So arrange, act, assert. We have the arrange step. We create the things that we want to test. Then we act. We perform the action that we want to verify or that we want to assert. And then we have the assert step with the assertions at the end. And this is verifying that we get the outcome that we expect. Sometimes arrange, act, assert needs to be in a slightly different order, then it becomes arrange, expect, act. This is, for instance, the case when you want to test exceptions. You need to set up your expectation that you expect an exception to happen before you trigger the action that triggers the exception. So we have the arrange step, the expect step, and the act step. Slight variation on that. Sometimes this is called assemble, activate, assert. We assemble the data resources they intend to use, activate a target method, and assert that some side effect from that method is within tolerance. That is a competing definition, if you will, of the other AAA, the arrange, act, assert. This is just for completeness sake. Okay. Another principle that comes up often, but not necessarily with regard to testing, but to software development in general. Don't repeat yourself. Try. Every piece of knowledge must have a single unambiguous authoritative representation within the system. And this also holds true to some degree, to a lesser degree, as we will see in a bit, when it comes to test code. So for instance, we have a test case class with a couple of test methods where we do very similar things. So if we have, for instance, we have a test for something that is called an article, and an article is supposed to have a slug. So we have our test has slug method. We create the object we're interested in. we arrange our test fixture, we create the article object, and then we assert that a method on that object works as expected, that we can retrieve the title from that object, and then, sorry, that we can retrieve the slug from that object. And then we have the next step, the next test, where we once again create the object that we want to test. And this is exactly the same code that we had just before in the other test. And this time we are interested in the title, and that is duplication that we would like to avoid. Don't want to repeat ourselves. And that can be eliminated, for instance, by introducing a setup method. That is a so-called template method that is automatically called when you declare it. Setup is automatically called before each test of your test case class. And we can use that, for instance, like here, to create the article object in one single place and store it in a private property, and then use that private property in our two tests, thus reducing the amount of code that we need in our tests on the one hand. On the other hand, we eliminate duplicated code, put it into a central place. And this makes our tests easier to read and understand because we have separated out the arrange step. If you do not want to name your setup method setup, and there are different reasons why you would not want to do that, then you can use an annotation. You can name your method any way you want. You just need to tell PHPUnit that this method should be executed before each test. And today you can use the before annotation for that. And in the future with PHPUnit 10 and PHP 8, you can use attributes for that. You just import PHPUnit framework attributes before, which is the before attribute that PHPUnit defines. And then you add the metadata using real syntax on line 9 to the create article method, telling PHPUnit using that new mechanism that was introduced in PHP 8 that this method should be executed before each test. And this is actually one of the attributes that already works in the current development branch for PHPUnit that will become shortly PHPUnit 10. However, what I have started doing a while ago, and I cannot really put a finger on it or put it into words, why I started doing that. I just observed that I started doing it. I no longer use this automated mechanism of a method that is automatically called by PHPUnit, no matter whether the method is named setup or some other name and then the before annotation or attribute. I prefer these days to have a method, a private method that has a return type declaration, and then I return the object I want to test there. This, to me, at least, that is part of the reason, makes it easier to read in the test code itself, because it makes it very explicit. I create the article here, and this is the article object I use, and it's not implicitly there that I need to know. Of course, I know how PHPUnit works and how the setup mechanism works and so on, but I still prefer to seeing explicitly written down that this article object is created, while at the same time still eliminating the code duplication that we had before. Okay. Another way of dealing with code duplication, especially when you need to test something, a method that implements an algorithm, for instance, with multiple data sets, is to use data providers. And for that, you can add parameters to your test method and then define a method that provides the data. And for each data set that is provided, this test method is run as a separate test step. So this allows you to decouple test code from test data. And in this example, we are testing calculating the magnitude of a vector. Our test is parameterized using m, x, y, and z. And the data provider annotation tells PHPUnit the data for this test comes from this data provider method, magnitude provider, that returns an array of arrays. And for each array, our test is executed once with that specific data set. So we talked about dry, don't repeat yourself, and almost everything has an opposite. So of course, dry has an opposite, and the opposite of dry is wet. So what does wet mean? We edit terribly, or we enjoy typing, or write everything twice. And trust me, there is a website where there are at least 24 different explanations of what the acronym WET is supposed to mean in the context of code. But these are the 3 at the top of the list. So what is wet? So wet doesn't really give us anything. So there has to be a middle ground between dry and wet, and that is damp. And damp means descriptive and meaningful phrases. And what this principle means is we should favor readability over uniqueness. Sometimes when you eliminate code duplication, the result is far less readable than what you had before. Yes, you had code duplication before with the potential problems that code duplication brings with it, but at least the code was readable. People that did not have a look at the code before or didn't look at the code in quite some time, they could get a grasp quickly by looking at the code and did not have to think a lot about what could this code mean. And then the code duplication was eliminated and suddenly the code was far less readable. Favor duplication over the wrong abstraction. Sometimes you need to introduce an abstraction to get rid of code duplication. And sometimes you choose the wrong abstraction. You choose an abstraction that is only really applicable and useful for part of the places where the code is duplicated and not so much for other places, telling you that yes, sort of in code there is duplication, but that is more or less by accident, that 2 different things that may or may not, that probably mean different things, just happen to be in the current state of the code base to have similar or exactly the same code representation, and that should not be abstracted into the same thing. So favor readability over uniqueness and favor duplication over the wrong abstraction. Why? Because duplication is far cheaper than the wrong abstraction. And there's a little bit of research on that. If the abstraction is wrong, it takes a longer time to realize that and understand the code than dealing with the fact that you have duplicated code. So dry increases maintainability by isolating change risk to only those parts of the system that must change. That is useful. But damp increases maintainability by reducing the time necessary to read and understand the code. And like everything else in life and in software engineering, you have to make a trade-off between duplication and readability, both of which are aspects of the internal software quality maintainability. So it's not really hard to get that right, but it's something that you need to take into account. And it's generally not a good idea to only have one goal in mind that you optimize for. Say, for instance, we must not have any duplicated code in our code base. Yes, you can do that. You can strive for that. You can achieve that. But along the way, you sacrifice other aspects of software quality that may or may not hurt you more than the duplication that you had before. Okay. Talking about data providers earlier, and this is, I think, a really useful output of PHPUnit, especially if you do test-driven development and if you carefully think about the names for your tests so that you can use your tests not only as a rather technical thing that verifies that your software works correctly, but when you choose good names for your tests, then your tests can act as so much more. They can act as an executable specification and documentation of your software. And you can look at this output that comes from PHPUnit based on some naming conventions that you can use, and you get an overview of what the tuple object in this project is about, what its responsibilities are, how it works, how it is used. And you can see, for instance, things like, hey, a tuple can be divided by a scalar, or the magnitude of a vector can be calculated, and so on. And you can look at that output. You can show that output to a non-developer. Say, in this case, the domain expert would probably be a mathematician, and say, hey, you probably do not know anything about PHP and software development and coding, but you know the domain, you know math. And this is how I understood this concept from math called a tuple is supposed to work. Did I get that right? And you can have a meaningful discussion about the domain by looking at this output. Maybe you missed something, maybe you misunderstood something. And the beauty of this is that this is automatically generated by running the tests. So when all this is correct and you get the green check mark everywhere, then you know that your software not only works correctly with regard to how you as a developer who wrote the code understood it, but also it works exactly how the domain expert expects it to work. And that is really nice. And there's a really nice additional cherry on top feature in PHPUnit, which is a test docs annotation that allows you to get useful test docs output for tests that use data providers. You can use placeholders that automatically get filled with the values that are passed from the data provider method to the test method for a specific data set. This is where, for instance, the magnitude of vector 1.000 is calculated to be 1, comes from. That is what we see on line 9. Yep. So leaving the context or the space of writing tests, looking at other areas where tests can be improved. I think, or I hope that it came across that I so far talked about what can you do to improve, to optimize your tests with regard to the code of your tests. Now let's look at other aspects where PHPUnit can help and where you can get better with your testing effort. Finding code that is not tested. This is something where the software metric of code coverage comes into play, a feature that PHPUnit has supported for quite some time. This is what the HTML report for code coverage looks like, for instance, for the div component that I have on GitHub that is used by PHPUnit. For instance, when assertions for equality of texts and strings and arrays and so on need to be calculated. Basically, a PHP implementation of the div algorithm that you find in the div Unix command line utility, for instance. And this is what the code coverage report for that looks like. This is the project level overview where we get the directory structure and the files and so on. We can navigate through there, for instance, to a PHP source code file, and we can scroll through there and we see, for instance, code that is not executable, that has no background color. We get to code that is highlighted in red or green, meaning if it's green, this is a line of code that is executed by at least one test. If it's red, it's not executed by a single test. And then you can either delete the line, or much more likely, it tells you that you need at least one more test. And if there's a green line, you can hover over that line and you get the information which test is responsible for that line being green. And that is a really powerful tool to understand how good your code base, how good your test suite is, which areas of your code base are covered by tests. But of course, you can always do better. And one way of doing better is telling PHPUnit which areas of your code, which code under test, which units of code a particular test is interested in. And you do that through the covers annotation. And that allows PHPUnit to give you a much more precise code coverage report that does not lie to you. So what happens here is this differ test has two covers annotations that tell it, hey, PHPUnit, no matter what code is executed by these tests, please only generate code coverage for code that you find in the differ class and in the unified diff output builder class. All other code is discarded. The motivation for that feature comes from a time when Zend Framework 1 was current, and you were able to run a single test for Zend Framework 1, and you would get over 40% code coverage for the entirety of Zend Framework's code base, because that one test executed a lot of code while it was only interested and only verifying a small, like 10, 20 lines of code method, but all the other bootstrapping was necessary. And that code coverage report is lying to you because you run this one test and 40% of the entire code base are marked as green, and you do not notice that that code is only executed along the way while something very, very small is being tested. And when you tell PHPUnit, I'm only interested in this, and discard all other code coverage that is being collected, you get a much more honest code coverage report that really tells you what is being tested and what is not tested yet. Talking about code coverage, the question that usually comes up when I talk about code coverage is, how can I make it faster? The good news is that it got a lot faster over the last year, year and a half or so, without you having to do a lot of things. And that is on the one hand due to a rather new code coverage data collection extension called PCOF. And it also has to do with the new version of Xdebug. If you do not want to use PCOF for code coverage because you say, hey, I already have Xdebug installed, that's fine, because Xdebug 3 is a lot faster, significantly faster when it comes to code coverage data collection compared to Xdebug 2. But PCOF is for line coverage still a lot faster, as we will see in this benchmark. And creating this benchmark took me quite some time, as you will see in a couple of seconds. So the baseline is, and I'm using the diff component from GitHub that you can find on GitHub, and you can run these benchmarks yourself because, hey, it's a benchmark and lies, damn lies, and benchmarks. So if you don't trust me, run it yourself. With PHP 8.0.1, running the tests without code coverage takes 22 seconds. Running the tests, collecting and reporting line coverage using PCOF takes 168 seconds. And it also takes a lot more memory, like 3 gigabytes versus 87 megabytes. And grain of salt, this library is very special. This is like the really hard case for benchmarking anything in PHPUnit, especially when it comes to code coverage, because the algorithm that is being tested has a couple of really tight loops that run a lot, and there's really much computation going on. Running line coverage with Xdebug takes 234 seconds, takes less memory, at least takes less memory as reported by PHPUnit itself at the end of the test run. but the only thing PHPUnit can report as memory usage is memory that is allocated through PHP's own allocator, but Xdebug does not use that. It has its own allocator for its own data structures. And I cannot give you an amount of memory that Xdebug uses for that. Sorry about that. It gets really interesting when we get to path coverage. Path coverage is the more advanced code coverage metric that is not line-based, but really looks at the different possible execution paths in your code. And there are a couple of industries where 100% path coverage is required, for instance, for software that runs in the cockpit of a plane. Side note, I don't really know how useful that metric is considering what happened at Boeing recently, but then again, that's not an industry where I'm at, and that's an industry where hopefully no PHP is used. But anyway, it's a really interesting metric, but it has a problem. It's really slow. It took me over 25 hours to run the tests that run in 26 seconds without code coverage just to get path coverage data. And that is quite a lot. But grain of salt that I mentioned earlier, this test suite is really special. It is really slow. So if you do this on the ray tracer library that I have on GitHub, it's 5 milliseconds versus 4 seconds, which feels a lot more real, more natural when it comes to the factor how it is slower. But yeah, benchmarks, I don't really know how useful they are, but they should give you at least some idea. Yes, path coverage is interesting, but it is really slow. And I don't think that there's anything that can be done to improve that a lot. It's totally normal that you get slowdown for collecting code coverage. That is nothing specific to PHP. When it comes to line coverage, things have improved a lot. I'm not really optimistic that they can improve as much as it did recently for line coverage, for path coverage in the future, but please prove me wrong. And maybe that's some, but then again, it's not really a problem because path coverage is not something that you look at every time you run your test. At least I don't do that. And I can't really tell whether or not I don't do that because it's so slow or because I'm not interested every single time in path coverage. I only do that every once in a while, but I don't use it, for instance, in continuous integration. Another way of looking at code coverage is putting code coverage into perspective. Don't just look at these numbers that come out of the reports. There are certainly areas in your code that are more important than others. There are certainly also areas in your code where it's much easier to write the tests for than for other areas. And the problem that a lot of teams run into from my experience, especially when they start adding tests, is that they write the tests for the areas where writing the tests is easy, but that's not necessarily the code where the tests would be most useful, because that's not usually the code where really bad things can happen. So just two examples I want to give you of how you can think a little bit differently about code coverage, and that is patch coverage and change frequency. So this is what I usually get when I get a pull request for PHPUnit. This is a service that I use to keep track of code coverage over time, called CodeGov. And one thing that it does is it looks specifically at the code coverage for the lines of code that were changed by this pull request. And I have much higher confidence in the pull request 97% of the lines of code that were changed have been...
We just missed the last 5 seconds.
Sorry?
We just missed the last 5 seconds or so. We just had a hiccup.
Okay.
But go
on. So this is an example of patch coverage telling me on a pull request that of the lines of code that are changed by this pull request, 97% of those lines are covered by a test, giving me some additional information when I review this pull request, that the risk is rather low, or is considerably lower than when there was, for instance, no test at all that would cover the lines of code that were changed here. Of course, everything by itself is not really meaningful anyway, but getting multiple different angles on the thing usually really helps. The other thing is change frequency. Not a lot of people know that, but there is a command for Git called effort. In a Git repo, you can type git effort. Then it takes a couple of seconds, depending on how much history you have, to calculate this. And then you get a list sorted in a descending order with the source code files of your project that are changed most frequently. And from my experience, that is really a good indicator for where you should start with tests, where you should focus on testing when you get started with writing tests for an existing project. Because tests are, of course, tests are always valuable, but tests for something that changes a lot are a lot more valuable than tests for something that only changes every 10 years. So just have that as an additional metric. And of course, you can take the output from that and write a little script that takes this as an input and the code coverage for the current state of the project as an input, and see of the source code areas that change the most frequently, how good is the code coverage for those areas. And if I had more time, this would be one of the tools that I would really like as a ready out of the box to use tool to use. But maybe if one of you is looking for an interesting idea for a new open source project, take that idea and build that. I hope that I have a couple of minutes left. Finding risky tests. PHPUnit can do analysis of your test while it runs your test to help you find tests that are not really useful. You can, for instance, require tests to have a covers annotation. You can let PHPUnit complain about tests that produce output where there's code executed that prints to standard output, for instance. You can let PHPUnit complain about tests that have a to-do annotation. That's probably the least useful of these risky test checks, but sometimes it's still has use cases for that. Yeah, sorry, I made a mistake. This one is, of course, be strict about the covers annotation. This lets PHPUnit mark a test as risky when code is executed by that test that is not expected to be run based on the covers annotation that we mentioned earlier. And force covers annotation tells PHPUnit every test needs to have a covers annotation. Yeah, and if you turn all of these on, that's what people refer to as the German mode for using PHPUnit, because Germans want everything to be strict, be that as it may. You also do not want to have codependent tests. Remember from the first properties, you want isolated tests. And here we have a test that sets a global variable and then does something. And then we have another test that expects that this global variable is set. And we run that with PHPUnit and it works until one day it doesn't. And this will be really hard to debug because you do not know that test 2 depends on the first test, but PHPUnit can help you uncover that if you run tests in a random order, and it's suggested to run your tests in a random order to make mistakes like that obvious. Because if we run test 2 before test 1, then that global variable is not set. That makes it obvious that something bad is happening. Of course, there's also, if you have too much time and memory, you can tell PHPUnit to run each test even more isolated than usually. And global's backup enables a mode where all global and super global variables are backed up before each test and are restored after each test. This is resource intensive, but it uncovers a mistake like that as well. Wanted to talk about test organization. You can have multiple test suites that you define in your PHPUnit XML configuration file. What I usually end up having there is unit tests, integration tests, and end-to-end tests. Basically, the main layers of the software testing pyramid. And I organize my tests into separate directories, and these separate test suite elements in the PHPUnit XML configuration file allow me at the command line to say, please run only the tests from the unit test suite. This, for instance, also makes it possible to have separate steps in a CI pipeline where you only run the unit tests first. And if that is successful, then and only then do you run the integration tests. And if those are successful, then and only then you run the end-to-end tests. And you can all do that in the same test suite and select with the command line option which test suite you want to run. On a more granular level, not on this high level of directory structure, you can organize tests using annotations. There's a generic group annotation that allows you to tag a test, if you will, in one or more groups, in this case, into the group business. There's an alias for historic reasons for group called ticket, where you can either put a ticket number or a ticket URL from your issue tracker. And the idea behind that is, especially if you do test-driven development and you work on a new feature, you tag the tests that you write while working on this new feature with the ticket number that describes the feature. So later on, you know what tests you wrote when that feature was implemented, in theory, among other things, allowing you, when business comes to you a couple of years later, hey, this feature we no longer need it, please remove it from the code base, that you delete all the tests that are tagged with that feature, and then look at the code coverage and delete, or at least get an idea where to start looking for code that can be deleted now that the feature should be removed. Again, in theory, I've seen it once or twice happen, but of course, only when the team is very disciplined and consistently uses these annotations and so on. But it can work. There are special groups with special semantics, small, medium, and large. So small is just an alias for group small, but PHPUnit has some special semantics for small tests. So for instance, you can enforce time limits on small tests. You can enforce that a small test does not talk to the network or the file system, basically does not leave the context of the PHP runtime. Sometimes that's useful. That's why it's implemented. Small, medium, large also has an effect on the color in the code coverage report. Lines of code that are covered by a small test get a darker green than a line of code that is only covered by a large test, for instance. And on the command line, you can use list groups to get a list of all the groups in case you do not know what groups you have. And then using group or exclude group options, you can select the tests on a very granular level that you want to run. And now I'm almost done. I would like to leave you with a couple of suggestions. Do not write code, meaning do not write programs that are cryptic, that are hard to understand. Write software in such a way that you yourself understand it today, that you yourself can understand it a year from now, that your teammates can understand it today. Write programs that you still understand tomorrow, write programs that your team understands today. But remember that your job is not to write a program. Your job is to understand and solve a problem. For me, tests are a very powerful tool when you do test-driven development to understand a problem and then solve the problem. But that only works if the test code is also clean code, if it's readable and maintainable and people can understand it. And with that, I'm done. I hope that this was useful, and I'm looking forward to your questions.